You're live. That's what it says. All right. So I'm hoping my internet connection holds up. I'm hoping the stream doesn't drop. This is going to be a fun talk here. As you know, I'm Robert, and I'll kind of go down the line here. Go ahead and introduce yourselves, people on the call. Maybe
All
Tyler.
right, I'm Tyler Baker. I'm the co-host of this with Robert. Yeah, and then we have a special guest. We have a few more joining here in a moment. Mike, you want to introduce yourself?
Sure. I'm Mike Scott. I work with Tyler at Foundries.io. I'm an embedded engineer, and I got roped into coming and spending some time.
Roped in, huh?
Should be fun.
Yeah, so welcome to devEco Live. This is a stream that we host on the devEco YouTube channel. People who might be just tuning in, or you, Michael, who might not be aware of this, we launched a Discord server almost a year ago now. And on that Discord server, we call it the developer ecosystem. And we have basically a bunch of communities in there, right? So, people come in there and they just kind of congregate around their different communities, but it all lives under this developer ecosystem. We thought, hey, all these people are doing all these cool things. Talk to Tyler. Let's do a stream and talk to people about the stuff that they're working on. Similar to, the old school 96 Boards open hours. I don't know if you remember that one.
That's old school. That was fun.
Yeah. Foundries.io. Tyler, I mean, I don't know. Do you want to give an introduction to Foundries.io?
Yeah. Well, we don't need to do the founder's introduction. I think people can go to the website and look. But I'm kind of more interested in what Mike's background is. How did you get into Linux? How did you get into software? Maybe just tell a quick story of kind of how you got here.
Oh gosh! All right, so I should first explain. I'm kind of the old man on the block here. I'm nearer to 50 than 40. So my Linux experience is kind of a funny one. I got started. I joined the Air Force, and I heard about this Slackware thing that you could load up on sort of older 386 boxes. And so back in the day, you had to download it for like, I don't know, hours. And then when you did the install, it would come up to this just plain, really terrible looking Windows manager. But I thought it was the coolest thing because you could totally configure it on your own. You could run it on like any box you wanted. It was totally, you could do these services from your home that usually you had to, have bigger boxes to do. And that was kind of the beginning of my sort of early on, Linux. There's some other FreeBSD stories on an Amiga 2000, but that was really where I got started with Linux. But what's funny is, it took me a lot longer than that to actually get a job doing it. It was mostly just tinkering for about 10 years, and then starting into Android and getting into kernels and bootloaders and all that stuff. But my history is actually like 15 years as a biz dev consultant working on, Visual Studio and, consulting so that I used to help clients get what they wanted out of their like legacy packages. And so you do these crazy band-aids and help them, get what they wanted to do. But it's been fun. It's been a wild ride to see how things have changed. I mean, you have to imagine, 2010 on like this, old Droid 3 or something with a pull-out, keyboard on it compared to phones nowadays, which are amazing. It just basically blown away.
I regret not getting into too deeply into computers back when I was younger. I mean, I'm 34, right? So you got a good 30 years on me. I'm just kidding.
So I got a question, Mike. Since you're old school,
Me with the punch cards going.
What was your first computer? What was the first like desktop computer that you had? Was it the Amiga
64.
or did you have something before that?
I had a Commodore 64 when I was it was 1984, I was born in 1972. So yeah, I was about 12 years old, 11 years old. My grandparents, big spenders that they were, for Christmas, totally. My mom was strapped for cash. She wasn't going to be able to buy us much for Christmas, and they were like, "Hey, so we heard the kids were riding their bikes to the library and spending like 2 hours a day typing in programs, only to like leave it at the library. They got this new personal computer called Commodore 64 thing. You think they would like that?" And my mom was like, "Oh yeah, that sounds kind of like an interesting idea." And so they laid down. It was like $350 or something, and it had a regular, like a regular TV style monitor you had to buy for it and everything. I mean, it was a crazy purchase back then, but I basically owe my entire programming career to my grandparents who took a chance on a Commodore 64, 40 years ago, basically. 35.
Oh, that's an awesome story. That was also my first computer, so that's close to my heart in terms of how I got into this whole business. Hey, look who
What I
showed up
find-
here.
There he is.
Hey,
Oh,
guys.
sorry. Look at we have Andy Doan that just joined here.
This is like a reunion for me. I haven't seen Andy, Ricardo, or Michael in forever. I mean, you and me, Tyler, we talk a little bit more, but Ricardo! Oh my gosh.
Ah, we got Mr. Salvetti here now.
Wow.
Hey,
This is
how's
crazy.
it going, man?
Good. Okay, so we got a few extra people here. So you kind of just heard Mike's Scott's background. We have Andy Doan and Ricardo Salvetti on the call. They all work at Foundries. They're engineers that work there. Andy, do you want to just kind of give a quick background about maybe how you got into computers? Like, what was the genesis for you? And then we'll go to Ricardo next.
I'm late to the game for most people. I bought one for a word processor before I went to college, and I was taking a class where kind of learning, I guess like basic, but I was from a small town. The teacher didn't know how to do it. He gave me like a manual, and I started playing with that, and then really the kind of unlocked moment for me. The computers came with gorillas.basic, where you throw the bananas and explode the other. And I realized like you could read the source code to it, and boom, I was just locked. And then we had Turbo Pascal game, and I realized you could change how it worked, and yeah, I was hooked. So,
yeah, I kind of got. I had a
would have
similar
been Windows
pathway
95.
in video games.
You say your first computer was Windows 95?
Yeah, it
Oh.
was 1996 when I was graduating. So yeah, it had I think it had like 8 megs of RAM, which was just unheard of. I mean, it was a pretty powerful computer at the time.
Cutting edge.
I can't place
Yeah.
I can't place the exact date, but maybe someone here can. Of course, I could probably look it up. But I mean, I remember going from MS-DOS, like loading my games with those 5-inch floppies, and every time you walk into another room, you have to put in another disk. And I remember going from the MS-DOS, loading my games that way, to Windows 3.0. And I don't know what year that was, but I don't know, was anyone else kind of in that era, switching from command line only to like the first
yeah.
Windows machine?
It
That
had
just
to be
blew you away. 'Cause that was the
mid-90s.
first like UI you got to
Yeah.
see.
93 to about 95 was when most people were switching. And it kind of went Windows 3, Windows 3.1, and then all of a sudden you could, or not Windows, but like MS-DOS 3. And then you could have it start automatically. That was the big thing. Like by the end of it, it would just boot right to Windows. You didn't have to like go to DOS and type something in to get Windows to start.
Oh, that's true.
Okay. It's kind of crazy.
Yeah, so I was.
Well, so I got a story about Windows 95 for you guys. So on the release date at midnight, and I'm from Washington, so Seattle, Microsoft in Seattle and all that stuff, right? My dad and I stood in a line at Future Shop. I don't even know if there's still a business anymore, and waited for Windows 95. And so we were at midnight. I was a young kid. We got home and it was like 2 a.m. We're like, let's install it, right? Of course, we're going to do an upgrade from 3.1 to Windows 95. Well, it turns out we didn't have enough resources to run Windows 95 on that system. So we ended up having to buy a new computer to run Windows 95. And it was a little disappointing, but yeah, that was kind of a memory that'll last me for a while.
Isn't that the story though of every upgrade you've ever tried to do? Like you're like, oh, this is gonna be great. I'm just gonna do this, little operating system upgrade here, no big deal. And then you're like, I've got it. I need another hard drive. Oh, I need a new.
That's why nobody likes updates, right? Because it just seems to make the things worse, or it makes everything slower when you get updates.
The funny thing with the embedded engineers, the rest of the world keeps advancing, and we're still stuck on the same command line with the same serial console that hasn't worked in 25 years, and we just keep hoping it will work this time.
Yeah. Okay, let's go to Ricardo real quick. Ricardo, how did you get into software or get interested in computers? What was the genesis for you?
I don't remember much, but I mean, like I used to play. I didn't back then. Like I didn't have a computer at home, but like we were usually like just playing with other kids that like were fortunate to have one, and just like like playing with stuff around with MS-DOS, and like playing like switching disk as Robert said, and like with Windows 3.11, right? I think that was the name. and just trying to understand like what are kind of like the I think what got me well like the magic commands and where we're kind of behind it. Like you were talking with the computer and writing commands and expecting results. That kind of like blew my mind back then. But I think what really it kind of got me was like I used to play a lot like like Wolfenstein 3D and Duke Nukem like a lot. And so when I got to Duke Nukem to kind of design my own levels, so and hack the game as well. So that is kind of like when I got that impression that I could build stuff, like visually as well. Like and kind of understanding how the levels were programmed, and like how we're done, and just like how you could do that with the language and so on. That kind of got me into like coding and understanding the internals as well. And so because back then like you would understand like like to have, for example, better sound on that game, you had to have like certain sound blaster, like what are the memory that like because you could like offload the mids like to have a better drumming and experience and so on. So you kind of had the grasp and a better feel of the hardware, right? I remember I had to buy like memory for my video card back then, and I was extending like from 1 meg to 2 megs, so I had like to plug in the memory and so on. So it was pretty nice, and it got like the real touch of like the real hardware, right? And just kind of understanding what was going there. I think that is basically what kind of drove me and still drives me today. Like I'm still working on the same kind of stuff. Just like
man,
understanding how
you
the
said
hardware
Sound
works.
Blaster. I just got a like I haven't heard Sound Blaster in so many years. Oh, that's
So
cool.
yeah, that's pretty much it. It's still basically the same thing today, just more powerful, harder, more bugs. Like hardware runs like firmware nowadays, which is basically so it's software everywhere, and you need to debug everything because nothing really works properly.
So you're saying all this time nothing's really changed all that much?
No. It's just like more fancy stuff, but it's basically the same.
I'm
we gotta give a
interested.
shout out to the comment. Oh, good.
I'm sorry. Go ahead. I'm sorry.
I was going to give a shout out to someone in the comments. So I
shot JR.
Yeah, I saw JR IRQ management. That guy hit it on the head. That hasn't changed in many.
Yeah, that didn't. Yeah, we had like to select on the sound card, like in RQ, because it was conflicting with another RQ. So like imagine that for a kid. Like, what is an RQ? But yeah, I'm still like playing like these days. I was like working on a USB driver, and I had to select the right RQ on the hardware level. So it's the same.
And back in the day, you couldn't just go Google it. I mean, you had to actually sit down and like figure it out. It was no easy way out.
There was no easy button back then, that's for sure.
You had to read the manual, like really get the manual. We're getting the registers, and like it was fun.
And then the first search engine, I think, like the big one was Alta Vista. It's like, but yeah, no. So I'm actually curious about your entry points into Linux, because I think that this is for me at least, it's a big topic, because I only joined kind of this open source world, Ricardo, 5 years ago, something like that. Ricardo hired me, by the way, a long time ago. So, woo, thank you again. But yeah, right now, like if you look at Linux and you're talking to just someone out of school or someone that's never really experienced working with the kernel or working at this bare metal layer, right? This level, it's got a pretty high barrier to entry. And so I'm kind of curious to hear your guys' stories. Michael was saying that, he goes way back, you were kind of towards the earlier times of Linux. I think pretty much most of you probably have somewhat similar stories, but I'm kind of interested in hearing those stories. Like, what got you into working on Linux? What, if anything, were some of your trials and tribulations? And then, what kind of advice might you have for someone who's getting into Linux now? Because, like I said, that barrier to entry is pretty high. Who wants to start on that one?
So Mike kind of did it. I'll start, and then Andy, Ricardo, you guys can jump in. So I kind of started where Mike did as well with Slackware, with like a million DB or CD-ROMs, I think it was, or there was a floppy to like bootstrap it, and then you had to feed
Good old
this
Slackware,
ROMs in your like 2x CD-ROM drive. It was like, and then of course it never worked, right? Like it would like start X would never work for me, right? So I just got stuck on the command line, and I was like, well, this is a kind of a useless system. So yeah, I mean, I kind of dabbled. I did DOS and 3.1.1, and then Windows 95, and then I think the one that really worked for me the first time was like Fedora Core. You guys remember that? I think that was Fedora's, like they used to call it that for like the first 6 revisions, and then they went to Fedora. But I was a pretty heavy Fedora user, and then I got into like FreeBSD for like the networking switches and stuff like that. So then that was kind of, it's not Linux, but it was like, you know, Unix based type stuff. And then from there, I, you know, just started using it like as my desktop, right? Because it was, you could get all this stuff for free. I think I was cheap and I didn't want to pay for all the stuff. And, you know, I was kind of younger, so I like didn't have a lot of expendable income. And then as I went into college, like, you know, it was mostly focused around like, you know, C++ and Visual Studio, right? And I was the guy using like GCC and like, you know, G++ to compile all the stuff on Linux. And so my professor was like, you know, you're making this hard on yourself. It just works on Visual Studio, right? And I was like, well, yeah, but I mean, I can take this home with me and work on my stuff, and I don't have to go to the computer lab at school, right? And so that was always interesting to me. And then yeah, I started getting into doing embedded Linux around the time like Android first came out, kind of like with Mike, right? Where it was like, hey, we can actually have a mobile operating system based on Linux, and it's like open source, and you can have all the code. And then from there, it's kind of spun, you know, into doing Linux on everything, and like Linux just took over the world. So that's kind of my story. Andy, Ricardo, you guys want to go?
Yeah, sure.
Story.
I picked it up in, it was 1998. I was in college, and I kind of remember the frustration. I was taking an assembly language class, and we were doing it on Windows 98, Windows 95, and man, you touched the wrong thing, and boom, it's just all gone. There's this you had to like copy and paste these little Windows segments. It was awful. And this guy was like, "Hey man, there's this thing called Red Hat, and it's just free." The funny thing in hindsight, to me, the best thing that ever happened was I tried to do it and it just didn't work. Like you said, like Start X didn't work. And there's kind of a personality amongst a lot of people that do this. Like it not working was the best thing ever. It became my like only focus in life to make X Windows come up on that computer. And I basically didn't rest for a month until I got it going.
Without Google, right?
Yeah, you know, now it's the same thing. You know, you just hit these like problems in it, but you just feel compelled to chase them down. And yeah, because you had the source and all. So
Yeah, I
yeah,
think that's kind of my story. Like there's like that old GIF that I shared like previously. You know, the guy is just like something is broken, then goes and try to fix the other stuff, and he goes and try to fix the other stuff. I mean, like that's the thing that with open source, like for me, like I think like since the beginning, because I have the ability to change things, is like from this engineering mindset, like, you know, like just I need the source, because then I you know, like I need, if there's a problem, I need to have a way to fix it, right? I mean, like my mind doesn't really work with black boxes, right? I mean, I just feel like, you know, like it removes all the power from you, right? You're dealing with something that you cannot change, you cannot fix, right? If there's a problem, you can do much. You can only use, like, and that is kind of what bothers me the most, and what got me into, you know, like as well, like Slackware, and you know, like and RHEL, and in Brazil we have like a Connectiva Linux, which was like RPM based back in the day, and I think like Red Hat bought them at some point. So there were like a lot of Red Hat users around, and you could buy like Red Hat like CDs and magazines and so on, and just play install it, because of course I didn't have like fast internet to download the tons of like RPM packages. But then, you know, like Gentoo, like I used Gentoo a lot back in college as well. So yeah, I think just this will of like just understanding what is going on and being able to fix it. I think that's the real kind of the power with open source. You can, especially if you're like a college area, like, you know, like if you want to study how the internals work, you can only do that with open source, right? Otherwise, it's kind of like what Tyler was saying. You can go to a lab and use like a proprietary, you know, like I don't know, like solution or framework or whatever, and you're in a university, but you're then unable to reproduce that environment at home, right? Because you would have to pay a lot of money and so on and so forth. And with open source, you can have the same kind of experience, like in college and later in work and home. So it's all the same.
Yeah, and I bet you no one got into open source or Linux because of the money, because back then no one was paying for it, right?
Back then
there was no money in
ones.
Linux at all or open source.
Well, not yeah.
You should have been in the room
When
I told my father-in-law I was leaving IBM to work on open source. It's like, so wait, my daughter's future depends on people giving you money to give away what you work on?
Wasn't one of the first companies to actually really capitalize on open source? Wasn't that Red Hat?
First company to make $1 billion doing it.
Yeah, big money is Red Hat. Yeah.
Yeah. So I mean, I guess like the way I look at it with regards to open source is, especially when you're talking about students and your ability to take this stuff home with you. But I feel like not only that, it's like students are kind of held to some of these proprietary entities, right? Call it, and yet when they get to the real workforce, when they get into the workforce, they're sitting down there and they're actually on RHEL. Like their companies are running open source software, granted possibly massively customized for that industry or for that company, but I mean, like, they're very much working on these Linux machines, and yet their entire school career they're on a Mac or a Windows, and they're not really learning how to use some of these things that are in industry. Now, I mean, granted, if you put in the extra work and you go just jam out on a command line, you're going to get it anyways, and it's not hard to pick up. But still, I mean, I feel that a lot of times schools aren't reflecting what's actually being used in industry. So, at least nowadays.
How do you think that's playing out with now Chromebooks? So now you're taking sort of like a mainstream version of Linux. It's now easier to access. You've got people that have a little bit of a tendency to like hack on them a little more. It runs on very inexpensive hardware. Could that be the next sort of, what is a new person going to pick up? This is where I go when I think about how do new people get interested in Linux or a derivative of Linux. And I look at Android phones, I look at Chromebooks, I look at some of these other new things that are kind of fun to play with.
Yeah, I think that's the Trojan horse, Mike. I think you picked a good example there. And why I say it's the Trojan horse is because on the surface, from a normal user who knows nothing about operating systems, they don't know it's Linux, right? It's a web browser, right? And I can go do things on the web browser. And if you start to get interested, and I think Google's done a great job here from that perspective, is you can make it into a development machine. Like I'm actually doing this on a Chromebook right now. I'm a huge user of Chrome OS, and you can start up a real Linux machine in a VM in a container. It's called Project Crostini, and you actually can install Debian packages. You can actually run X apps inside that container that will run on your desktop and use the same X11 server. So I think it's a good gateway to get people into Linux without having to be like, hey, they can install Linux and then fight through all those problems. Like, you get a running Linux system, and then you can work backwards from there, rather than what we had to start with, right? Where it was nothing works, and now we have to learn all about it now. So I do kind of agree. I think it's going to be the Trojan horse if it's not already.
And you could download and build it now. So it's kind of like the new Slackware, where you got an old an old laptop laying around. You can go install it with Chrome OS or something and just start tinkering for relatively cheap, I think. So be interesting to see how that progresses.
Yeah. Okay. So I've got a question here. I don't want to run us out of time too much here. I think we have a little bit of time left, but I want to ask you guys, since you're old salty Linux engineers now, what is your least favorite programming language and why? And anybody who wants to start on this one, go ahead and take the floor.
I know which one Andy's going to talk about, so I don't want to steal his answer.
Well, I mean, y'all are all waiting on my. You guys are all waiting on my C++ rant, so I'll just jump into it. So, a disclaimer: I do this daily, so I still, it pays my paycheck, but C++ to me is the most dangerous language ever invented. I feel like, actually, even when you the people that know it really well, you start talking to them, and eventually they'll admit to you that they just feel like children walking around with a shotgun. It's just no safety on, and there's all what's that DJB, that famous programmer. He's got this like website of like 10 examples of like perfectly reasonable C++ code, and then it's like, gotcha, here's how it fails on you. There's just I forget the word they call it. It's like the intellectual burden you carry as you're reading stuff, and like Python, it's the lowest intellectual burden possible, right? Every line's what it seems, it's really safe. C is actually, you're always worried about where the memory is, but it's kind of a low, there's no magic behind it. In C++, it's just the highest intellectual burden possible. Every line of code, you think you know what it means, but is that auto pointer really safe? Who knows? Maybe not. Does this don't just disable them because you can't do those safely, right? I don't know. I still write it, but it scares me.
It seems like it gives you enough slack to really hurt yourself. Where C does that, but in a different way, right? And are helpful in some cases, but like you said, they can be abused, right? And so the experience isn't always the same when you're working on different C++.
And on the a high burden isn't necessarily awful. Like I think it looks like Rust kind of has a high burden to me on that, but the high burden you pay gives you all the safety. So like if you're willing to sit there and really think about it, you get this. You think really hard about every line, and in the end, you still blow yourself up. So.
And it's terrible to debug as well, right? I think,
You don't like demangling symbols? Come on.
And it's funny, as compilers have gotten better for C, warning you about different problems and different things. They really don't warn you as much with C++ because it's just so complex and you can shoot yourself in the leg so often. I don't know why. I just feel like it hasn't progressed.
Just leave a semicolon out every now and then if you think it's a good language, and watch your 1,000 line error and try to figure out where it came from.
Yeah, I feel like, I studied electrical engineering, and I feel like C was the language that if you learn C, you kind of prepare yourself for all the other languages, minus some syntax, right? Of course. But I don't know, like if you look at Stack Overflow and you collect data, like some of the most popular languages out there are, Java, JavaScript, C, Python. Like those are kind of taking the lead right now, and so everything's kind of being built on those. They're actually beating C. Like C is like 5 or some odd down there somewhere. So like Python is really taking the lead right now. I don't know. What do you guys think about Python? Or did everyone agree on the C++? Was that like a 3 and 0?
No, I have an old crusty one that I hate, but I'll let Tyler go first.
Go ahead, Mike. I want to hear it.
So, and this is just more bitterness on my part and being old and so I don't know, like at what point in college and everything, when you take that Turbo Pascal course and it's like, this is kind of useful, but it's still more of a learning language. I wish there was something that I could directly apply all my knowledge to and maybe get a job doing. And back in the day, they had this language called Modula 2. I don't know if you guys have ever heard of this. And I took the time to learn this thing. I mean, I wrote modem routines in it. I really thought I had a career as like a Modula 2 programmer. And that thing died off so fast. It was kind of a bigger, better version of Turbo Pascal that kind of had some library functions. You could do all sorts of stuff. But I just want those 2 years back now. It's a complete waste of time. And it was like, I hate it. So I hate that for different reasons than Andy hates C++, but that's my rant for the day on Modula 2.
So I got a question for you, Mike, since you're our resident modem expert. As far as bringing modems up and configuring them, how much has that changed over the years?
Oh God, we're still living in the 80s. I mean, it's still AT commands, and I mean, you go out and you look at like the 3GPP stuff. It's like, here, we're just going to build on the next thing. We need another function. Just bolt that on. I mean, nothing has changed in like 20 years. It's insane that we don't have a better answer for some of this stuff. But yeah, I didn't know if you knew how to run modems 20 or 30 years ago, you still know how to run a modem today. You start off with an ATE0 to get your echo turned off or something.
Even cellular modems, right? I mean, they don't really differ in that.
Yeah, it's all the same.
They're all modems underneath the hood, which is just, I mean, it's interesting for the people that probably don't have any kind of visibility into that. But yeah, like literally, if you were working on a 9600 baud modem in like the early 90s, you probably know how to configure a radio interface today.
They've done some neat things with data layers now where you can enter like data modes where you can just do pure, because the overhead of sending AT commands back and forth with like actual data in it is kind of high. But at the end of the day, yeah, at some point you're still going to break out an AT command. It's It's really quite funny.
So I'm actually curious on this one because as far as I know, you guys have to have worked the layer below C, like in assembly. Have any of you done any like assembly?
We did a risk we did a risk 5 port to Zephyr, or at least Mike, Ricardo, and Marty, who used to work with us, did, which was below C. So like they had to set up all of the assembly routines before they could actually get to jump into C. So yeah, I think most of the group here probably has. But Mike, Ricardo, you guys want to add anything to that?
We're going to very quickly go back to the IRQ management question with the the risk 5 port was so bizarre because you think that the product is kind of ready for production, it's ready for people to start using, but then with this port to Zephyr, you realize how much is still being worked on. I mean, in this particular chip was kind of an NXP model, so they used a lot of the IP that's in most NXP cards and just mirrored it over to work on like risk 5 type stuff. But there were just some of the most bizarre problems you'd think that would be fixed by now, that you just had to kind of reinvent and work. We had like stacked IRQ system where the core chip could only handle so many IRQs. So now we're going to echo and have another bank of IRQs over here. So then you have to read which one that was, and that driver didn't exist. So you just have to write it. But fun times.
Yeah, I remember taking a couple courses on assembly. I honestly kind of liked it. We were dealing with very, very minimal chips, right? You're talking about just several registers, and you just plug stuff into the register. It's very top down. It's very sequential. It all just kind of made sense. I remember writing a Fibonacci piece of code, and you're just like, yeah, it just kind of makes sense.
I kind of have this idea that people, it's hard to when you talk to a guy, that it's hard for them to explain how they conceptualize code. But I've started to realize I think people kind of conceptualize in like what a line of code is. And I've hit a point in my life, like my line of code abstractions, like what a line of C code does. And I forget that, like assigning a variable a value is actually, all these assembly language instructions underneath it. And even like when I write a lot of Python code, that's probably most of my life. Even as I write Python code, in my mind, I'm kind of thinking of the lines of C that makes. So like my kind of baseline abstraction of what a computer's doing is lines of C, which is not really true at all. But I kind of wonder, like Ricardo and Mike were much lower in the platform than me. So I kind of wonder, like when you see a line of C code, are you thinking, load stores and stuff like that? Or you just kind of think that's like one clock cycle?
It's more like... yeah, you have to know so much more about the architecture.
Yeah, exactly. Even on C, like when I'm coding in C, I think more about like memory management than anything else.
I'm worried about the off by one error.
Oh yeah.
Yeah, that's why that's a good segue. So like one of my first programming languages that I really learned was Ada 95. They actually started us off in college that way, and it may seem odd, but it was because it was so tightly constrained, so that you like couldn't overrun arrays and stuff like that, right? Like the stuff that all the freedom that you get in C, you kind of became more disciplined to do that. And then we had I had this really good professor in college, and we basically made a train control system for these model trains. And your first assignment was to write it all in Ada and get it to work. And so you did. And then you bring your code over into C and recompile it. And what we found was our trains were crashing because we were running stacks over, right? Like it didn't translate, but we got to see a real life example of like, oh my gosh, we have to be careful. You have to be so careful with this, and you have to understand what you're doing, because if you don't, your trains are going to crash. And if this was a real life train, like you'd kill people. I thought it was a really good example of like, hey, you get all this freedom, but you need to understand how to control it. Otherwise it's dangerous. Right. And yeah, I'd say my least favorite language has to be Perl. That's me. I think I don't like about Perl, some people love it, is that there's like 20 ways to write the same code, like to achieve the same thing. So it's really hard to review it, and it's really hard to be like to argue your point, because there might be 2 acceptable ways to write it, and it just comes down to personal preference. So it's a really
C++ is a bit like that nowadays. There's so many frameworks and ways to do it. That is,
yeah, so 11, 13. Greg
exactly.
Crow-Hartman has something one time about like why they're so strict about rules for submitting patches of the kernel and like the code formatting. And he was saying over time, all the code starts to look the same when everybody does it so strictly. And he said you can literally, like, as you're doing code review, when it just doesn't look right, bugs jump out because they're not written correctly. And I do think that a lot of people don't like Python because of the formatting restrictions, but all Python code looks the same. And things, I think there's something to that. When you have to look at lots of code, bugs jump out quicker that way. So you're like, that something looks funny there.
Well, that's a good point, because what the kernel changes, like whether there's like 9 patches per minute or per second. I don't know what the number was, but I mean, it's an insane rate of code coming into the kernel. So being able to quickly look at something and be like, no, we see this all the time. This doesn't look right. Go fix this. You're doing, you're casting it wrong here. Speeds up the maintainer's job, provides fast feedback to the developer, and then a better, end product once those patches get merged. So yeah, that's a good point.
I shot JR commented on here. He says at University of Michigan, they had an amazing course called EECS 100, where they started off with binary instructions, then ASM, then C, and it was amazing. But now it's all just Python. So
I think it's fine in a way. I think there's a lot of people looking at Python because it's a lot easier to start with that language, and there's a lot of patterns. Even like, for example, in the way that the code is built and the way that it writes the indentation, like there's rules for everything. So it's a lot easier, I think, to grasp at this point, like for people that are starting up. And if you want to go in a lower level, like for example for C and so on, it's not that complicated later on. But I think it's a good language for introduction. And you can still like script basically things with Python, right? You don't need to formally, have like everything in a way that that is not. You can still build it in a way that can match later on, like with a more like a C-based language, for example, if you want as well.
So I got to ask this one. Did anyone watch Silicon Valley, the show? You seen it? Or,
I stopped it because it was too close to reality. Like
it's too close, yeah.
Okay, so back to Andy's point, where like everyone kind of has their own ways of doing things. There's an episode, I think maybe it trickles into a couple episodes, but there's an episode where the main character gets a girlfriend, and the whole argument happens around spaces or tabs. Is this something that happens in the real world? I mean, like, are you, Ricardo, ever reviewing Andy's code and say, like, why the F are there these spaces here? Just use tabs, damn it, or not?
It's normal.
All the time.
Ricardo actually caught a code review the other day where I accidentally mixed one in. It was a file that kind of had mixed indentation or something. It got mixed up. In my editor, it looked fine, so I didn't realize I'd mixed them up. But the diff, it was the tab was 8 spaces, and it looked awful. And he's like, "Hey, man, fix this." So, yep, it happens.
Okay, but so like, let's go down the list. Like, what are you? Are you spaces or tabs?
I guess it depends.
No tabs on Python. Spaces on Python.
Yeah, spaces on Python.
I'm actually I'm a pretty big fan of tabs. And I spend my life in Python, so I guess I'm open-minded. But tabs give people, tabs solve the problem. Do you want it to be 4 spaces or 8? Well,
I think one thing that is nice with open source, and one thing that I see a lot of people talking about it nowadays, is that when you're creating something from scratch, of course, like you can set up your own set of rules. But one thing that that you kind of end up like learning as well with open source is learning to work with other people, right? With code that was written by other people. So one thing that that you kind of need to be aware of when you're starting up contributing, for example, a project or so, is finding the patterns that are used on that project, and you simply just mimic the patterns, right? For example, if one project prefers tabs, then just use tabs, right? If one project prefers spaces, then just use spaces. Then you can match yourself with whatever because it's not, you're not be the one maintaining the code, right? So you need to kind of to convince the maintainer to accept, and and through that process you need to go along with whatever rules that are written by that maintainer, right? So to be a good citizen. And then coming back to a point, like, one thing that I think that people should start doing more, especially in college and so on, is teaching people how to read code, how to understand code. Not simply just creating, just get a language and create it and set your own things in here, but instead, like, how do you read somebody else's code? How do you review a code change? You know, like how can you adapt your kind of, you know, like pattern to, you know, like a certain project and so on. And because this is kind of real life, right? I mean, like when you start like working with other people, those are kind of the skills that are critical, right? How to use, for example, Git, how to review code, and how you like to adapt on whatever. Because one thing that I hate when you see someone contributing, for example, is just they're the ones kind of pushing the rules as you, and when you're the maintainer, you know, like that doesn't actually work, right? You need kind of, so all of this like tabs and space and so on and so forth. It really depends in the end of the day, right? It's more about, you know, like what are kind of the patterns that you should use depending on the project.
Like being ready to adapt and being malleable to the situation.
Yeah, you know, when I joined Linaro, they I got on a couple of kernel mailing lists, some of the like lower activity ones. I think maybe for a while I was on like the OMAP one because I was doing one of those boards, and it wasn't too high traffic, but that was one of the biggest learning experiences I've ever had as an engineer, was watching that mailing list, because I wasn't looking super close, but you see how people do things. So like you see this feature and you see how the best engineers in the world break it up into these really small commits that each one you can make sense of. And it really teaches you how to structure your thought as a professional engineer. And I mean, no project is as rigorous as the kernel is on that kind of stuff. So it's not, it's kind of a pain to go subscribe to that. But even if you don't understand how the kernel works, you understand like what a change looks like, and you see how people do their thought process becomes very similar. Even for each like change set, it'll be a different thing. You know, like this is a Wi-Fi driver and this is some USB thing, but the way they do changes is always the same. And it's just really beautiful and brilliant to watch how they do that.
I mean, I remember not too long ago, I mean, I was learning Git, right? And I've done several hackathons at university level and at a professional level, right? So like, you know, talking like AT&T Summit, where literally people fly from all over the world and go to try and win a lot of money, right? This is what they do for a living. And then there's the ones that happen at schools. And it's very surprising in some cases to see students don't really understand the whole, first of all, version control, and they're sometimes seniors, right? Like graduating with a computer science degree, and they haven't used version control. They're working in, you know, Visual Studio or some big clunky IDE, and they have never used a command line /GCC to compile. Like you're like, yeah, write your C code and compile it. You can do it on this Dragon Board 410C, right? And they're like, okay, where do I start? I'm like, what's your favorite text editor? Like, just write it. Like, that's it. Like, have you used Vim before? No. And so, okay, you know, these are kind of like some of the situations that we're dealing with, and you know, ramp up time for these types of things when they get to companies suffer, you know. So, yeah, I don't know why I brought that up. I feel like it was because
that's a good point.
It's a great point. Yeah, every new engineer has to kind of go through this process, or at least once you come out of college and you have one way of thinking where you kind of control all the variables, and then you join a team, and all of a sudden everything just goes kind of out the window. You've got to start, like Ricardo said, you kind of got to be more malleable as far as adapting to their coding style. You've got to learn how to operate as a team as far as source control, communication. Everything sort of changes. I think that's the growth that you go through the first couple of years out. You can be the best coder in the world, but if you can't work with other people, you're not going to be very functional.
Well, when you get started, you take this big chunk of code, and you're just getting started. You just figure out how to make it work, right? Okay, I changed all these files. I don't know what I did, but it works now. That's how that's how everybody gets started. And the problem when people start getting a version control, they're like, I just want to do this giant commit, push it up, and then tell some guy to review this thing. And what you have to start to learn is to make someone be able to read your thing, you've got to break that down. And that commit history teaches the reviewer that what you did makes sense and they can trust it. And that's a hard thing for people to get good at. It takes time, and you got to watch other people do it, like you, Robert, was saying.
Yeah, and I mean, also,
I don't know. In a way, we need to like point people to like great code. Like, here's a good mailing list where people do things right, and it's not so high volume that you can't keep up with it. Or like, I've never told anybody, like, I like to read code. When I was doing Python at Canonical, Barry Warsaw worked there, and he writes the most beautiful Python code. So I would just, like, anytime I saw him making changes on a project, I would read his pull request because it was just beautiful. I was like, oh, so that's how you this is how big boys write Python. You know, it was really cool.
So
yeah, it's a good segue actually to one of the questions that we just got asked on the live stream chat is how would somebody get into kernel development, right? I think that's a question that a lot of people like. You know, they're like, oh, I'd love to contribute to kernel, but how do I get in there? It's a huge project. It's very intimidating. I'll give a little background on kind of how I got started in it and like maybe some ways to get involved because like what Andy was saying, like there's a format, and so reading patches and understanding good patches is like a really good first step. So I worked on vendor kernels, if you will, you know, back when I was doing products, and essentially that was easy because you could just hack the kernel. Like you could just delete code and be like, all right, I don't need that. That's causing us a problem, so don't do that, right? But that's not good because you can't upstream that code, right? Like unless you're making those changes for good reasons that are generic, they're never going to take it. And so if you want to work on like upstream kernel development, you know, that's kind of a daunting task. So we started a project called kernelci.org, which is out now, a Linux Foundation project. It was basically like, let's start testing the kernel like on real hardware. That's how I got into it. And through testing the real hardware, we started to find bugs, right? And then you would work backwards, bisecting the kernel, trying to figure out what patch created the bug. And then if the patch was something that you felt comfortable fixing or saying, hey, you know, here's where the bisect log is, it pointed to this patch, we either need to revert it or we need to change the code slightly so that it works properly in all these cases, you know, you could start to contribute there. Now, Greg Hartman, runs a program called Kernel Janitors, which is like a place, I think if you just Google search it, it's basically like, here's all these like low, like easy tasks for people to get started with on kernel development. And then there's a mailing list for it. So like you can kind of post your patches, get a pre-review before you go post them on the mailing list. And one thing I would say is like, honestly, don't be intimidated. Don't be scared. I've been yelled at by many people on the mailing list. It's hard. You have to develop thick skin because people are passionate, like about Linux. Sometimes they're a little overly passionate, right? And they could use words that like, you know, feel like a personal attack. But honestly, it's because there's so much writing on Linux these days. Like the entire internet is built on Linux. So I've got 2 patches in the memory management subsystem, which are terrifying because every single computer on the planet that runs that kernel, there's a code path through that. And if you did something stupid and it gets into production and crashes 25% of the internet, I mean, you're going to be blamed. You're going to be named for that, right? And you'll never get, no one's going to ever want to take your patches. So choose the right subsystems to get started with, find the easy stuff and ease your way into kernel development. That would be kind of my spiel there. But you guys, if you got any suggestions on how to get into kernel development, go for it.
I want to add one thing here. So this is probably something that's more of like a philosophical approach or theoretical approach, but I think the first thing to do to get into kernel development is to learn the history of it and to find a good book and, you know, read why it exists to begin with. Like why was Linux created? Why did Linus Torvalds sit there and make it, right? Like, you know, where did it start? And so like there's some really good books out there that you can get. I think like one of them is written by a guy from Red Hat. I can't remember the Linux Bible. Like if you just go buy the Linux Bible, it's really not that expensive. Once you get past those first 3 chapters, you know from the moment it was conceived until where you are now and how all these licensings and the universities that added to it. And there's just so many subtle things that you learn just knowing the history. Now, I never really got into, you know, that thick-skinned situation with contributing to the kernel. I've never contributed to the kernel. But I was pointed to a really nice resource by Matthew Poirier from Linaro. The Udiptula Challenge. Has anyone heard of the Udiptula Challenge? Okay, so I'm going to just share this. I'll share this in our chat, but it's definitely worth checking out. What it is this person who puts together this challenge that literally goes through, I think it's like 10 steps. You send an email to the list there. Right now they're not taking applicants, but you send an email to them, and then he responds. Everything's kind of automated, and he takes you through from like a hello world contribution to the kernel all the way to like this super difficult contribution. And so you can kind of go through this process, and every week or when you finish your submission, a new email goes out with a new challenge. And when you finish it, you should have been, you know, supposedly accepted into like that world, right? Thought it was pretty interesting. I'll share it in YouTube too. But yeah, that's my take.
There's quite a lot of materials there. I think but one thing that I mean one thing that I liked when I started working on this is just the program, right? As any other program, it's just like the OS itself, right? So if you break it, you need to reboot it your machine. But I mean, is just to see code in there. And but one thing that you need to kind of I think it's more like for the kind of people that are really into the OS itself, how an operation system works, how memory works, devices, and so on. Because this is just like a you know, how you code an OS and just how it is kind of structured in the end. So if you like, you know, how, you know, like the internals of an OS, then I think, you know, like there's several ways to start like working on this. Like you might start like, I don't know, like investigating how a driver work, you know, like how a simple, you know, like a USB or Wi-Fi and so on and so forth, and then just going on. But I mean, like for me, what really kind of worked is just because I'm kind of a fixer, and you know, like I need to understand why something's not working and I need to find a way to fix it, right? It's just kind of my nature. So what happened is just like, as I was running Linux on my laptop, like for example, suspend wasn't working, or the brightness the control wasn't working, or the sound
Still
wasn't
don't.
working. Right. So, you know, like I would just kind of go, you know, like and see the bugs and start like, you know, like pinging people that could know, you know, and understand more about it. Because sometimes is simple as like, for example, the maintainer doesn't really have the hardware to test on, the hardware that you have. So, but he can guide you through on how to fix, you know, like the issue, and then you can start like contributing that back and so on and so forth. So for me, it's just what really kind of works is just like finding bugs and issues. There's easy bugs, right? There's always kind of, you know, like those sort of bugs, and just trying to understand how to debug and so on. That kind of is what kind of works for me, at least.
You got to start small too. Like
Yeah.
you can't just show up as a stranger to some.
Right.
I mean, if you think about it, like just socially, it's just how you can't just show up and unload something on a person if they've never met. You got to start to develop some trust, do some small things, and then yeah, I try to tell all. I see a lot of junior engineers make this mistake. They start off on a big thing and they don't really talk about it up front, and you get too far down the road, and you lose contributors like this all the time. By the time they get it all done, they submit it, and it's too late for the maintainer to be like, well, that's a bad idea, and I needed you to do it this way. And so you need to send out a feeler. If you want to do something of a big scope, you need to talk to the guys ahead of time and be like, hey, I kind of have this idea, what do you think about it?
Yeah, they call those RFCs usually, right? Requests for comments, where you basically spell out your idea on the mailing list. And it's much better, like as Andy said. And if you have some like skeleton code, right, you can post your patches there to kind of spur a conversation. Because, like, yeah, Andy said, sometimes they'll be like, this already exists. You just need to use device tree in this way, and you can accomplish the same thing. Or, yeah, that's a good idea, but I'd like it implemented like this, or use this subsystem to make it more generic, right? It's very important to do that. Also, one thing, just go ahead and configure get send mail, like the first thing you do, and make sure you can do that, because you're going to need it. And sometimes people stumble over that. And run check patch too. Just it's easy. If you do a patch, run check patch, because you will get nailed for that right off the bat if you don't do that. So
Every now and then I've found I sometimes get functionality into a project by just threatening them with code. They're like, oh God, I don't want this guy's code. Like, I see his idea, I'll just do it my own right way. So, you know, sometimes just the threat of giving them code will spur action.
I love it. All right, we're kind of getting to the end here, so I want to wrap up with one last question. It's going to be short. What is your editor choice? Vim, Emacs, or something else? We will go ahead. Anybody want to jump in? I'll say I'm a Vim guy. I'm not much of an Emacs guy. I know Emacs can do everything. I keep it simple and kind of stick to the Unix philosophy of do one thing well.
Yeah, I'm a Vim as well. Like, yeah, I wanna see like Mike, but I'm a.
So in our company, we
started back in the day.
The going joke is we had this huge debate, Vim versus Emacs, and at one point, I'm listening to two of our engineers discuss this, and I step in and I go, "Wait, you guys don't use gedit? I mean, what's wrong with gedit? It's kind of like a notepad for us, And you have to understand, from my background, is I came from the biz dev world where, you had to have like windows and stuff, because you were always having one window open for editing, but you had another window to do something else, another window to do something else. It's not really like a server background where you really need to be able to do all this stuff on the command line, which is like what Vim and Emacs and stuff are really built around. So to this day, I do all my embedded coding in gedit, and it's
So what when you have to get into a device and open files? I mean, are you just using whatever
I use
editor?
Vim.
Yeah,
I still, I know Vim, and I actually kind of like Nano, which is another kind of dirty, dark secret, but I'll use Nano or Vim or one of them. I'm not an Emacs guy, I'll put that.
Yeah, I mean, that's kind of how
one of the most prolific engineers I've ever met.
Prolific with one arm tied behind his back.
You know, people spend all their day like making their IDE work just perfectly, and here you've got Mike Scott, who's one of the best engineers in the world, and he just opens up gedit and hacks at it. You know, actually, I believe it could have changed, but a long time ago, I think John Stoltz uses a pretty basic editor, and he does his development on a Chromebook. He's one of the major kernel contributor, like timekeeping and
You know,
stuff.
that's a good point. We should actually bring John on, see if he'd be open to it, to kind of explain his workflow on a Chromebook, because that's kind of interesting to me. I mean, I've always liked the idea of trying to develop and do my workflows on a Chromebook, but I switch either to OS X or I go to vanilla Linux to do that. That might be a good
programming heroes.
He's done a lot for Android open source project and the Linux kernel, and like he's a really good resource as well to help get started. I mean, he's got patience to help you and to get started and get your patches in shape. So he's a good all around guy. I second that.
We should definitely ping him. But yeah, on that note, like, I mean, I'll say, like, for my text editor, it really depends on what I'm doing. Like, I've done some web dev, and on that case, I'll pull up Atom on my Mac, right? Like, if I'm doing just committing stuff to, my branches on GitHub and I'm using my command line, most likely it's just quicker to use Vim. And then in some cases, I'll find myself using this other program called TextEdit, right? Because you can actually mimic documentation, right? And you can get these markdowns and make it look like how it would look in the markdown version of the document when you stream it into your GitHub repo. So like, it really kind of, for me, it depends. But I have a few programs.
It is really up to like whatever is more, I guess, suitable like for you at that point, like to do that. I still use Vim because like when I started like back in college when I was doing like CZadmin, I had to maintain those old, like Sun, HP like servers, and the only editor that you had like SSH and Vim. So and you had to do all the work, like through those tools. So like it just didn't change. It's just because it's the only editor that is basically everywhere. Yeah, SSH machine, Vim, and that's it.
Yeah, that's why I kind of chose it too. It was lowest common denominator, right? When any system, any Unix system you encounter, if you know how to run VI or Vim, you're going to be able to run it and edit files. You may not figure out how to exit out for a while, but eventually you'll figure out how to do that, and then everything's downhill from there.
Monty says my grandpa uses
the most Googled.
Oh, sorry, go ahead.
I was going to say that may be the most Googled like thing is how to exit Vim. Like people just realize they've written the best code in the world, and they're like, "Crap, I can't save."
When I first started using it, I was like, I just closed the terminal window down, and then I was like, oh, it's like leaving like sessions open. Like this is terrible. I got to figure out how to close this thing.
Yeah, Monty says my grandpa uses Emacs.
Wow,
if I could do it all over again, I would do Emacs.
I really would too. Yeah.
All right, that's the top of the hour. This is awesome. Like, honestly, thank you so much. You guys came in here. Thank you for spending the hour. And I mean, this is a lot of brain power and experience and knowledge in one place for this whole hour. And thank you for sharing all those stories.
Yeah, no, it was fun. Thanks for coming on the show and everything and sharing your perspectives. I think they were interesting. Hopefully, everybody else agrees. So. Yeah. Should
we do a quick selfie before? Maybe I can end the live stream. We say goodbye to the live stream, and then we do a quick selfie. I mean, I haven't been with you guys in so long, so this is so cool.
Yeah, we should probably get some context before we end the live stream. So we all used to work together at Lenaro. That's how. But then myself, Ricardo, Andy, and Mike, we spun out of Lenaro and created a company called Foundry. So we actually haven't been to we used to hang out all the time, and then now that we're different companies, and then Robert, you've moved on from Lenaro as well, so we're a couple companies removed there, so yeah, it's been fun to hang out with everybody. Good times.
Yeah, for sure. So I don't know, I guess any last words? If anyone has any last words, I'm going to end the live stream onto YouTube, and then maybe we could just do a selfie real quick.
Works for me.
Okay, cool. Great. So any last words, anyone? All right, then we all just kind of wave at the camera while I hit the end.
I'll give you a gavel bang that we use for our company. You ready?
Oh, there you go. All right, stream has ended.
Cool.
Awesome.